When you make breakfast in the morning, do you start the coffee machine and watch it brew the coffee before starting to do any other task? No judgment if you do, but I bet you probably do other things, like maybe toast a bagel, heat up the milk, feed your dog, and once the coffee's done brewing, you make yourself a cup of coffee, right? Well, that's great, because today I'm going to give you a brief introduction to asynchronous programming using Kotlin Coroutines while building a useful script to convert audio files from the WAV format to MP3s. Also, a big shout out to my friend Mike for the idea for this project. Check out his work at mhborthwick.com. Coroutines are a great way to write asynchronous code that is both efficient and easy to understand. They allow developers to write code that can be suspended and resumed later without blocking the main thread of operations. This is particularly useful for tasks that involve waiting for external resources, such as file input or output, network requests, or database operations. If you watched my to-do list app tutorial, we used coroutines in the first video to set up our room database. You're probably wondering why you should use coroutines in the first place. Well, traditional asynchronous programming often involves callbacks or complex threading mechanisms. However, coroutines provide a structured and sequential way to write asynchronous code by alleviating the complexity of nested callbacks and streamlining error handling in asynchronous workflows. And on that note, let's build our audio converter. Create a simple Kotlin project. I'm using IntelliJ IDEA Community Edition. And for my project settings, I've selected the Kotlin language, Gradle as my build system, and Kotlin DSL. Then go ahead and open your build.gradle KTS file. And within the dependencies block, you'll want to declare implementations for Kotlin Coroutines and for the Jave library, which we'll use to convert our audio files. I've added links to the documentation in the description of this video for you to access the latest versions in the future. And as always, don't forget to sync your project afterwards. Within the source main Kotlin directory, create a new class called AudioConverter.kt. And inside the brackets, create a new function called ConvertWave to MP3. This function should have two arguments of type file, one for the input directory where our WAV files are currently located, and another for the output directory where our converted MP3 files will end up. Now, because we want to use coroutines inside this function and want to be able to pause and resume coroutine execution without blocking the main thread, we want to mark this function with the suspend keyword. This also allows us to use other coroutine features such as the coroutine scope builder. You can think of the scope as the stage and each coroutine as an actor performing on that stage independently. We'll use the launch block inside the function to signal to our coroutine to begin executing or performing their parts. Now let's create 3 helper methods to set the audio and encoding attributes and process each file. The first method will create an audio attributes object and set the codec, bitrate, channels, and sampling rate. The second method creates and returns an encoding attributes object with the MP3 output format and the audio attributes from the previous method. And the third method takes the input file name and the output directory, which we'll use to define how to create the output file. Then inside the function, we'll use our other 2 helper functions to create the audio attributes and the encoding attributes. And we'll use the encoder object to finally encode and process our input file using our output file template and the encoding attributes we defined. And since these operations can fail, we'll wrap them in a try-catch block. Back in the launch block of the ConvertWave to MP3 function, we can begin building our coroutine. We'll first create the output directory using the output directory argument. We can then check that the input directory both exists and is in fact a directory. Otherwise, we'll print an error message to the user. From there, we can get an array of all the files we need to process by using the listFiles method and filter using the WAV file extension. And finally, we can loop through our files array using for each and call the process file method we created earlier, providing the file and the output directory. To run our audio converter, we'll need to define a main function where we'll define the input directory and output directory paths. From there, we can create an instance of the audio converter and call our convertWave to MP3 method, passing the two directories as arguments. Also, as a fun experiment, I'll time how long the extension takes using the measure time millis function and print the result to the console. Yay, it works! It looks like it completed in about 14.5 seconds. You'll probably notice that it's processing each file one by one. While these are being processed inside of a coroutine, we can drastically improve the performance using a feature called concurrency. To do this, we'll make a small modification to our conversion function. We'll take our files array and use the map function to create a new array. Inside of our map, we'll transform each file into a job by telling it to execute the processing of the file asynchronously using the async keyword. We'll also tell it to use the in-out dispatcher, which defines the thread where the coroutine should execute. The IO dispatcher is good for things like reading from or writing to files, making network requests, or interacting with databases. We'll collect all the jobs inside of a jobs variable, which we can then use to call jobs.awaitAll to wait for all the jobs to complete before exiting the program. Now when we run the program, it processes all the audio files at the same time, concurrently, and runs in about 3 seconds, which is less than half the time it did previously. Coroutines can be a bit tricky to understand at the beginning, but hopefully this gave you a good start and maybe a useful project to practice with. Let me know if you have any questions in the comments, and as always, thank you for watching. Take care.